in today's revision hackathon. In today's revision hackathon, we are going to revise the module 1.4 of your teachable course. So let me go ahead and point you out what we are going to cover today. So if you go into your teachable, let me share my screen. Share. Yeah, hope my screen is visible now. Great. So if you look at the module in yesterday's session, we have covered the exploratory data analysis lecture. Today, we are going to cover the make features lecture. Right. So people who are joining us for the first time, these revision hackathons are basically a revision of what has been covered by the primary faculty of the course. Right. So basically, this module 1.3 was covered by Jain sir himself. So we are going to cover this make features also. Right. Yesterday's lecture, if at all you would want to go through the direct lecture, you can go ahead and watch the lecture. Else, you can directly go through the revision hackathon directly. Right. So yesterday we have. Okay. So I would request people to mute. Okay, great. Thank you. Yesterday, we have covered a little about the exploratory data analysis. Today, we are covering the make features lectures, right? So when you go here and open this lecture, so this is what we are going to cover today, right? Okay. So let me share the link to today's revision hackathon collab file. So I request you to practice as we are doing it. So because doing is where this will have a stronger recall for everyone, right? So I've shared the link on the chat. You will be able to view the file. So it will be in view mode. You can go ahead, make a copy. When you make a copy, it is on your drive, right? So when you go to your drive, all your collab files are already there in your drive, right? So I request you to make a copy of it so you can run it parallelly along with us. So people who have recently joined, okay, so let me do a voice check. If my voice is clear, type C in the chat box. Yeah, thank you so much, Suraj. Thank you, Suji ma'am. Great. So we had a challenge in the first 15 minutes yesterday. So thanks. So now the link to the collab file is shared. You can directly go into your make features lecture and click on this file to even open this particular collab file. So even you do not have to depend on the link that is there on chat. You can directly go use the collab file that is there on the lecture. Great. So yesterday we have understood how to do the basic exploratory data analysis. Today we'll understand, we'll take a real time data set, another data set, and also understand how do we do a little of data cleaning as well. Right. So the objectives would be to understand a few concepts that we have already learned in our previous lectures. We are going to apply them and have a stronger understanding of the same concepts. Okay. So now if we go forward, first let us talk about the data set that we are using today. Yesterday we have used the data set of flags data of various countries, which was from the UCL machine learning repository. Today we are going to use this particular data set, which has already been uploaded to Pixeltests GitHub file. So this is a CSV file. It will look like that. Like it will look when you open in a browser, it will look more of comma separated. But if you open the same in sheet, sorry, you'll be able to see it in a more structured format, right? So the same file that you plan on using, you can even open it in sheets, right? So that the same file, if you use it in a file, so let me save this. Give me a second. I'm going to share the link of that also. Yeah. So if you see this particular data set that we are using here is, yeah. So in this, we are going to use this AIMAS houses data. And there are more data sets also available. So you can always go ahead and use other data sets if you are planning on to test by yourself. So this data, aims.housing, if I'm going to download it and open, you can see that this is more in a structured format. So when you open it in a browser, it will look comma separated because the CSV is a comma separated file. So you can see that this is the data that we are going to work with, right? So it's a huge data set. So the link to the same file is already being used here in the import, right? So if at all you have opened the link, the collab file I've given, you'll be able to see this here, right? So how many of you are able to open the collab file parallelly, right? If you are able to open, type me in the chat box, because we want to ensure that, yeah, people run it. Thank you so much, Suresh. So most of the times what happens is in our previous lectures, we just, I mean, the actual lecture, we more tend to go through, just watch it. We don't execute them. So that does not register strongly. So I request you to go ahead and open the file in a different browser so that you'll actually know how to, actually work with these data, right? So if at all you're opening for the first time, you'll see there will be a connect button here. You might have to connect, then only you'll be able to run this, right? If you do not connect, when you directly run it, it'll take 30 seconds or so and get connected, right? Okay, so I would wait for more people who are typing me, who are parallelly running this file along with me, right? So if you are able to open the collab file that I've shared, let me share it once again. Please go ahead and open it and run it parallelly, because a revision hackathon is a very good time for you to do practice or hands-on. Great. So if you're able to open the file, type me in the chat box. Yes, thanks, Vinita ma'am. Okay, so now the URL. Thank you, Sujit. Great. So now what we are doing is we are creating a data frame. You can use DF as usual, but we are creating the name of the data frame as house. And like yesterday, because it's a CSV file, we are using .read_CSV on the pandas alias. So we have imported pandas as alias PD. So now this data set that we have seen is being imported into the data frame here, right? So this data set in CSV is imported into house. So if you print house, you'll be able to see all these data set. You can see that there are roughly 1,459 rows in this, and in columns also there are 81 columns, right? See, the other way to also always know the how many rows and columns, you can go ahead and do house.shape. It will give you 1460, 81. So you will always be able to know the shape of it, right? Some of these usual checks that we do, I'm going to quickly go through them because we have covered them in our previous two lectures also. So house.head will give you the top 10. Actually, if you specify a number, it is going to give you the top 15 rows. So you can go through that data. Tail will give you the 5 observations towards the end, right? So dot info is going to give you a data set, a generic assessment of the whole entries. Like is going to give you the data type of the same, and it will give you the name of the column, right? So right now we have 81 columns in that. So like in this houses data, there are 81 columns. Like is what is the actual roof material, what is the roof style, what is the lot area, how is the neighborhood condition. So if somebody wants to take a decision based upon this data set, so it will be very informative for them. Like if you see first floor square feet, right? So it will give us how many SFT this one particular house is having on first floor, on second floor, on ground floor. So there are every data. If there is a garage, if there is garage, what kind of garage, if there's a pool, what kind of pool, the area of the pool, the sale price, the sale condition, right? How many years. So whole of the data you're able to get by doing the dot info, because here it will be difficult for you to see all the columns. Maybe you'll be able to see the different number of rows and all, but dot info is something you would be able to get the data type of each of the column as well, right? So you can see some of them are directly int or float object, others are directly given as generic object, where Python or pandas would not be able to directly identify the, if it is a string, integer, or a float, it will directly give as object. It can have string, integer, mixed data, or something like that. So we'll also work with that and also try to do a change of that particular data type as well, right? So this is how you can import any data set from online. We have yesterday seen how to import from your Google Drive or upload it directly here. So you've also seen that. So right now we are importing by URLs. Now, if at all you want to just have data types and you don't want these 2 columns coming in between, so you can do house.dtypes. We've done that yesterday. So it is going to give you a summary of like just the data type alone. Now, if at all you want to see how many nulls, yesterday we had a data type of Disney, and in that Disney data type, we were a marathon done by Disney. So in that there were no nulls. Let's check if there are any nulls in this houses data set. Right. So basically in all the columns, there are no data, no nulls, but only in this lot frontage, there are 255 nulls that it is able to tell us, right? So there is one column where 259 null values are there in that particular column, right? So this also is a little insightful, basically because we do not want to work with null data types or null columns, because we'll get unstable insights or biased insights, right? So it is always good to check if there are any null values, and if you directly use is null, it's going to give true or false. When you do a dot sum, it is going to give you the total number of null values there, right? So if you see dot sum, it is going to give you the actual value of null in the whole data set, right? Till dot sum, it is going to give you in how many columns where all there are nulls. But now you can see that lot frontage is one that showed 259 null data, but there is this 3 dots, which means there are many other columns where you are not able to see how many nulls were there. But if at all you are going to do dot sum again, so it is going to give number of missing observations in whole of the entire data set, right? So if you look at this whole data set, there are roughly, like if you see NA and not applicable and all those things, now you'll be able to make out that there will be roughly 6,965 null missing data, right? So how many values there could be? Now, if let's say, because there is 145, 1460, into 80. Totally, there should be roughly 1,18,000 cells. Out of those 1,18,000 cells, roughly 7,000 cells are having null, right? So this also we have checked yesterday. If at all, if at all we want to see a little more information, we use the dot describe function, right? So I'm going to comment the others. When you use the dot describe function, it will show you all the columns which have only the numerical values, where there was generic values, like let's just say neighborhood, good, bad. Whenever there were text, that would be excluded. So it gave us only 38 columns, because 38 columns are numeric columns. So you have an assessment right now that this data set has 38 columns which are numeric, where you can do some insight generation, right? So if at all you want to say give me include all, right? So this will give you everything. Now you can see that it has given all the 81 columns. Now here, this describe will give you some valuable stats. So it is giving you all of these rows have roughly 1460 count. So the count of each of the column is given. There is lot frontage 1201, right? Because we have seen that roughly 259 were null value, right? So 1201 plus 259 is 1460, right? So that is the reason only 1201 count is coming, which means the count will not count the not a number kind of values, right? So when you are calculating unique, it is telling that in ID there are no unique values, because ID is unique for each row. Similarly, subclass there is no unique, but in MS zoning there are 5 values that are unique. The rest of them are repeating. So that is what it will tell. In sale type, there are 9 unique type of values that are there. Sale condition, 6 unique type of condition. Sale price, there is no there's no unique sale price coming. Everything is different. So similarly, it is also giving you mean of all of it, right? So 1460's mean will come to 730, half of it. And you'll also know mean of some other valuable data like lot area. Now the mean lot area is 10,516, right? So sale also, the mean sale value is this could be in USD based upon the data set, but yeah, so it says 1,80,921, right? So you're going to get some insight from these dot describe function, right? So when you include all, you will get these non-numeric data values also, like top and frequency. If at all you just use describe, it is only going to give you numeric data, right? So the rest of the functions are also very similar. I'm not going to run these, which would when you say include number, it'll run as if the first function only. And when you say exclude number, it will give. So let us run this exclude number. So it will give you only data which is categorical, not just numeric. So because all the numeric is excluded, now all of these columns, there are 43 columns which are non-numeric. So you'll be able to run that, right? So this is about the describe function, which is something that we have also seen yesterday, right? So now we are using dot columns on the data frame. When you do that, it will give you the list of all the columns, right? So if at all you want to see what all columns are there, this will be helpful. Even this dot info also gives you columns, which is more informative. But if at all you only want the names of the columns, you can just say how's the data frame dot columns. You'll be having a list of all the columns, right? So if at all you want to just out of all this, there is one column. Let's just say here, yeah. So there's this column, and you wanted to have just the 5 rows of this column, right? So you can just go ahead, copy that name of that column and run it. You'll be able to see that bedroom above ground is these are the values that it has. So similarly, you can check for any other columns also. So I'm just saying house electrical dot head. So it is giving me SBRKR. So something that I'll also not be able to comment. Let's see central air. Yeah, so it says yes, yes, yes. So meaning that maybe central air conditioning is available in that particular column, right? So whenever you have the data frame name and within the square brackets, give the name of that particular column, it will list out that. So if at all you want to give two columns, I think this will for 2 or more columns. If you remember in our initial hackathons we have seen, you might have to include 2 square brackets, right? So let's see if there are any errors. Yeah, so it is giving me in the column central air. So there is central air conditioning in the first 5 rows, and the bedroom above ground, these are the values, right? So if we are clear about doing a little assessment overview assessment of any data set, importing an overview assessment of any data set, if that is clear, type C in the chat box. Better would be if you are able to run this also, that will be great. If it is clear, type C in the chat box. Thank you so much, Vinita. Right. So people who are watching us on our social channels, you can include it in the comment section or in the chat. Thank you so much, Suraj. Great. So here, there's one question, Jay sir asked in the actual lecture, what type of variable is this bedroom above ground? Is it categorical or quantitative? Right? Type C for categorical and Q for quantitative. What type of variable is this bedroom above ground? Okay. So basically, whenever it is, yeah, so Suraj, you corrected it right. So basically, whenever it is numeric, it is quantitative. Whenever it is non-numeric, it is categorical. Great. Okay, so now similarly, like how this is also similar, you can give any column name dot head. It is going to give you few rows of that particular column, right? So now there is this one lot frontage, which is giving me first 5 rows, 65, 80, and all of these numbers have been given, right? So here we can see that the data type given here is float, and these are, you can see that here they all have .0. So they are all actually integers stored as float, and that is the reason it is coming as .0, right? So if at all we want to see, we have also seen the value counts yesterday. It will give me the count of the whole values here. Like if you see, it will group all the 60s, and there are 60 SFT. There are 143 rows where it is 60, where lot frontage is 60, and similarly 70 where lot frontage is 70. There are 70 such rows. Where there is lot frontage 80, there are 69 such rows. So the value counts is something that is useful, right? Great. And we also got Vinita, you had a query, Vinita ma'am, you had a query yesterday. So we also, like, how to multiply the numeric will also come there. So similarly, if at all we want to see how many unique values lot frontage has, so it will give you a list of all unique values, right? And if at all we want to see the count of unique values, right? It will give, you can say n unique. When you do n unique, it is going to say 110 is the total unique numbers present in the column lot frontage, right? So here also it has given, when you are doing the value counts, it has given the length as 110 and the data type as integer. So here, a simple count also has been done. Like what Jason does is counts all of these. You can see that there is one NaN, right? So when you do dot unique, how many unique values this array or this column has, you can see all of the unique values present, and then there is one NaN. So what happens here is, if we count it, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rows, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 columns. So there are here 11 by 10, 110 unique values here, and there is one more value here, which means the NaN is not counted when you are counting dot unique, right? So NaNs are not counted in unique values, right? So you can be sure that whenever you want to say n unique, it will give you how many total unique numbers. So in this data set, okay, not 11 columns. So basically here we have just, okay, let me come back here. So lot frontage is this one column in this data set, right? So there is, so there is this one a column which is lot frontage, which has so many values in that. So in that there are not applicables, a few not applicables you can see, and there are a lot of 69, 60s, 70s, right? You can see all of that. So now what we are doing here is, we are saying, let's just say there is 170, there is 70 here and 70 here. So there are many columns, many rows where lot frontage is 70, and there are many places where it is 60. So what we have done here is, first we have did this value counts, dot value counts. Now here for us it is very difficult to count, right? Because it has so many columns, so we'll not be able to count it. So what we have done here is, we did dot value counts. When you did value counts, it is telling me in the total number of columns, the total number of rows, you have 143 60s, 70 70s, 69 80s, right? So this is what it has given. And there are so many columns out of that. So how many unique ones are there, right? So if at all you want to see now 60, like there are 143 60s and such like that, there are many numbers, and we want to see how many unique numbers are there, right? So let's just say this, for example, all the 60s are counted as one unique value, all the 70s are counted as second unique value. So that, like that, we are trying to understand how many unique values are there, right? So that is the reason we have first said dot unique, because if we sit out to count all of these, how many 60s, how many unique values are there here, we lose count every time, right? So that is the reason this function comes handy. You say dot unique. When you say dot unique, it says there is one value which is 65, which is unique. So it will give list of all the numbers, whatever is present in that. If at all it came once or twice or many times, it will give you one time. Like it says there is 60 in lot frontage, there is 65 in this, there is 70 in this, right? So it is given you the list of total unique values, right? So we just counted how manually how many unique values are there, right? So we counted, said there are just in this array, we are not counting actual columns, we are counting here when it presented, like here there are 11 and here there are 10. Okay, so it is 110 here plus one more minus one NaN. So it is true that here when you say n unique, there are 110 unique values. We are just counting how many unique values. We have not counted number of columns, we just counted unique values. I hope that answers. Yeah. Thank you so much, Linus. So now you can see that with help of some functions, some tasks that if somebody asks us to do some assessment out of this huge data sets, it'll be how difficult it could be. And with the help of a few smaller functions, you are able to do that, right? So some value count is something that will give you total values that are present and how many times each value, the frequency of each value, how many times it is coming, right? So this itself tells you there are 110 unique values and how many times each of it is showing up, right? So this is about unique and n unique. Now I hope that is clear. Now what we are going to do is we are going to understand what is this lecture, this make features about, right? So there is this role called feature engineering. Even Jay sir explains it in the actual lecture as well. So many times what happens is you might have to do assessment, write some features also, right? Something that is very specific to the data set. Let's just say there is a data set of all the people who showed up for a football match or a cricket match. And maybe you want to specifically know how many people purchased during break, okay, or like some time, right? So this is something that Pythons by default might not be able to, the pandas or NumPy might not be able to. So you can engineer a feature, create a feature, basically a function to generate data from the existing data, right? So this is also called making features, and that is what this whole lecture is about in Teachable, where we'll try to understand, we'll try to make smaller features. And similarly, we can always go ahead and make more complicated ones as well, right? So we'll see how do we go for making, as we go learn more data science model, we'll be able to make functions which will do some complex assessment also. But here to this lecture, we'll understand what is making a feature, right? So this is what, if the concept of making features is clear, you can type C in the chat box. Thank you so much, Suraj. Right. Thank you, Vinita ma'am. So now, so we are going to, thank you, Sujam. So what we are going to do, we are going to specifically look at 4 columns here, right? Let's say these 4 columns are total basement SFT, first floor SFT, second floor SFT, and sale price, right? So we are going to do that. And how do we do that? Whenever we want to get values of multiple columns, we use double brackets, right? So the name of the data frame and double brackets. When you run this, now you'll be able to see that total basement is this much. You can see that the first floor is 856 and the second floor is 854, right? The sale price is so and so for that particular building or that particular property. Okay, so now what we are going to do is we are going to make simple columns. We're going to which is going to give you an idea of making feature here. So we're going to make small features and adding them as columns here, right? So something very basic. So what we're going to do is even JSR also tells us that this is something as a practice. It's always good not to tamper with the original data set and always make a subset, right? So because if we go ahead and make some changes in the data set, maybe if you want to revert, undo, or do something, it might not be easy for us to do that. So it's always good make a copy or subset of the data set. So what we are going to do here is, out of the house, we are going to make a subset, a data frame named subset only, right? You can even name it as subset house if you are going to use multiple subsets, right? And you are mentioning all the 4 columns here and saying dot copy, right? So when you do dot copy, all of this 4 columns data gets copied into subset, right? So I'm going to run subset.head now. Okay, so first I hope I've run subset. So when you run this, you'll be able to run subset.head. Now you can see that, okay, so this has these 4 columns, okay. What I'm going to do, I'm going to create a new subset house because I have already used the data frame subset. So I'm going to say subset house, and I'm going to, on the subset house, I'm going to run the head, right? So now you can see the 4 columns. So what happened is I've already run some more operations, and that's why there are other columns. We'll get there, right? So I've created a new subset. The name of the subset is subset house, and it is a subset of the house, and it has this copy of these 4 columns, right? So if subset and copy is clear, type C in the chat box. Great. Okay, thank you, Nitam. So now on this subset, we are going to work and make it work on these 4 columns only. Now, because this is a subset of the column, you are not bothered about the all 81 columns. You're only bothered about your 4 columns, right? Because whatever you wanted to generate, the feature you want to generate was based upon these 4 columns, right? So now what we are trying to do here is, you can use subset. I'm using here subset house. Now the new data frame, which is the subset house, I am going to create a new column. If you remember in our previous revision hackathons, or if you have gone through professor's lectures, you can see that this is how you create a new column, right? So we have gone through this. Now we are creating a new column and giving it value 1. So when you do the subset houses head, when you run this, you'll see a new column by the name total square footage, right? So let me run that. Okay, I've run it now. Now you can see that the total square footage, there's a new column created with all values as 1, right? So now here we have not given any specific value, but directly given a 1 unique value, which is equal to 1. You can give it equal to 0 or anything as well, but this is helpful while you're creating a new column, right? We have created a new column, right? So if at all you see this copy, if you remember, if this copy you have seen, now this is something called deep copy, right? So when you do a copy, in that copy also, Jay sir goes and explains you a little change in the copy, what different types of copy, right? So for example, right, when you do dot copy function, all these columns are getting newly copied into subset house, right? So you are not operating on anything that is original, right? So that is the reason it is called deep copy. But there is another way. So for example, what you say is, I'm going to say new data frame. I'm creating a new data frame, and I'm saying it as subset house. What I'm saying is subset house is the new data frame. When I do this here, I am just giving it a new name, right? So this is shallow copy, if I'm right. Okay. So what is happening here is, the new data frame is nothing. It is always going to point to subset house, right? It is like board which is saying arrow there, right? It is always pointing there. So whatever changes you make in subset house or new data frame, so it will always remain similar, right? So this is what Jay sir explains. So when I do new data frame, it is nothing but a name for the another name for subset house, right? So if you understood the difference between this kind of copying and the dot copying, right? If you understood this, type U in the chat box. this is nothing but pointing to the actual data frame. Here we are making a copy, actually copying, right? So you can understand this like as a Xerox of the actual one. Here we are saying to to actually work on, make changes, go on to the original sheet one, right? So that is what it is, right? So here that is also diagrammatically explained. A shallow copy means you're just pointing. When you're saying A and B are two different data frames, when you say A is B, you are just pointing A and B both to the same data frame. But when you do a deep copy, you are actually having the same copy of it on both of them. Okay, so this is one point that Jay sir explains in the lecture also. Great. So now, okay, so coming back, we were here where we created this new column, total square footage. We have created the new column, total square footage. Let's actually work on that, right? So now what I'm doing, I'm saying subset house has 4 columns. In this, the column which is total square footage, what do you do is add subset house total basement square foot, subset houses first floor square foot area, and subset houses second floor SFT also, right? So which is actually, earlier it was just one. The one was helpful for us in creating one column, but when you want to actually have the value total square footage, you're just making one column. Yeah, and you're making that feature where you are adding all of the basement, first floor and second floor SFT, right? So now if you go ahead and see the subset houses head, you'll be able to see that okay, so I've not run this. Okay, so I've run this now. So when you see the subset houses head, you'll be able to see the total square footage is nothing but sum of first basement, first and second. Now it is easier for you to know that this was the total SFT and this was the sale price, right? Yes, right. So Vinita ma'am, that is clear. So because both of them are pointing to the same data frame, so that is what will happen. Yeah, so now that we have this new, I hope that is clear. So now what we are doing here is we are creating another column, which is a subset house, and the column name is price per SFT, price per square feet. And then we are saying whatever is there in sale price divided by the total square footage, right? So when we are running this, there's a new column that is getting created, and that new column, so let us try to print that. So now you can see that the price per SFT has come, right? So we have all of these rows have a new column, which is price per SFT, which is easy for us to understand that, okay, now we can easily compare, tell this is an expensive, this is cheaper than other, here it is a better deal, here it is not. So all of that is something that you can do now, right? So now what we are doing here is we are creating a new data frame, which is just subset houses price per SFT, right? Okay, so I'm going to run that. Okay, so now SRS has just one column, which is price per SFT, right? So if you look, when we said dot copy, we are going to do a deep copy of the SRS into SRS1. So this is just to make you familiar with the concept of copy, right? So now SRS1 will have a unique copy of its own, which is nothing but similar to the SRS we have created, right? So we've got it. Now what we want to do is you can now see that the first 5 rows are the price per SFT. So the zeroth or the top row, the price per SFT is 81, 71, 82, 56, 74, right? So now if you remember, we used the index lock, iLock, in our initial hackathons. iLock gives you, instead of directly pointing out to any specific index, it will give you the index number 3. So if I'm going to run this, now you can see that wherever the index is 3, which means 0, 1, 2, 3, iLock will bring that particular value alone, right? So if you have to specify index, because now it is very difficult to name each index, right? So, or that is the reason you can directly say what is the value that is there in the 1455 index, right? So when you run this, it is going to give me 67.30, the whole of the value, right? So this is what, and if at all you want to update any specific value, you're going to give equal to and give the new value. So when you're going to update this, the new head will have 5 in the place of 56, right? So now what we did is we worked on a copy. We have never touched the actual original SRS, which had the 56, right? So if at all now we try to bring up SRS, you can see that it will have the original index 3 as 56 only, but SRS 1, you can that it is what you call changed, right? You worked on a copy of it, right? So this is what we have understood till now, right? So here the even if you want to get the subset houses price per SFT head, you will see that it is unchanged. So if at all you want to know the type of this new data frame that we created, so you can always write in type and it will tell you it is series, right? So what is the difference between this subset house, the type of the subset house, which is a data frame type, and the price per SFT column, right? It is coming as series, and that is this data frame, right? So can anyone in the chat let us know, like, what is the difference? Why this is coming as a series, and why the whole subset house, which has 4 or more columns, coming as data frame? Yeah, you can even unmute and interact. Yeah, so people who are watching this on our social channels, you can put it on the chat as well. Yeah, so Pradeep says, here, you are right, Pradeep. The series, when you are having only one column or one row, it is a pandas series. When you have more rows and columns, it is a data frame, right? So because the subset house price per SFT only had one column, it is a series, right? So once you have more than one column, it becomes a data frame, right? So I hope that is clear. If the difference between series and data frame is clear, type C in the chat box. Thank you, Suraj. Thanks, Sunita ma'am. Thanks, Ravinder sir. Great. Now we've understood this. Yeah, so one pop-up question here is, why might you want to have the square foot price per square foot? Because it makes more sense for us to actually compare by having this price per SFT column than just having first floor, second floor, and third floor and price separated, right? So it is very easy for making us a decision. If we want to say what is the best property out of this, you can say in terms of just price, you are getting more SFT for lesser price here, or this is the highly priced one. These are the lowest 5 properties, and these are the highest 5 properties. You can do a lot of that. So definitely this column is useful, right? So now many times what happens is you can have conditions within when you are trying to create a new column, right? So we'll also try to understand that how do we use if and then statements to create new variables, right? So normally we are familiar of writing if statements and then else statements separately. But if at all you want to write if and else statement in if you're familiar of writing if else statement in Excel, right? So if you write if, I'm just giving you an example, if a, let's just say a is greater than 5, then you say comma, and what happens if the value is true? If it is true, if it is greater than 5, then say I'm just giving a greater than 5, right? Then if you put comma, it says else. What happens if it is false, right? Say not greater than. So this is what we do. Like if you see here, if I give any value that is greater than 5, it is going to say greater than 5. If I'm going to give anything less than 5, it's going to give me not greater than, right? So if you see here the same format, like if you can have a comma, first give a condition, then if it is true, what to do, if it is false, what to do, right? Similarly here also, what we can do here is we are going to use a comma to have a condition based upon if the condition is true, what to do, right? So that is what we are going to do here. So let's say we have our subset house, and then we are saying, let me comment the other portions. Subset house dot loc. Loc is going to bring me the create the row, right? So dot loc, and I'm saying if subset house, here the condition is this, right? First in the square brackets, I'm just first going to delete this and show you, right? So there are a portion before comma, which is going to be our condition, right? Here it's going to be condition. Here it is going to be what happens if it is true, right? What happens if it is true or false, right? So that is what we are going to do. So before the comma, what we are going to say, we are going to say subset of house and the column name price per SFT. If it is greater than or equal to 18, then high priced column, there is a column that is getting created, high underscore priced equal to 1. So what this will do is it will create a new column high priced, and it will set wherever the price per SFT is greater than or equal to 80, it will set as 1, right? So let me go ahead and first run this. So the subset house.loc, and then there is a condition wherever this column is greater than or equal to 80, create a new column high underscore price and set it to 1, right? So I'm going to print the head now. Subset house.head. Now you can see that there is a high priced new column that got created, and wherever the price per SFT was greater than 80, it said yes, it is high priced 1. Okay, so if this condition, how we have used a condition to create a new column and a new value in a new column, if that is clear, type C in the chat box. Thank you, Vinita. Thank you, Ravindra. So we'll see another example. Now you can see that wherever it was less, right, there it has become not a number, right? So let us also fill that. So what we are going to do, we are going to say subset house dot loc, and the condition here is subset house price per SFT if it is less than 80. So greater than or equal to 80 and less than 80, which will cover all values, right? If it is greater than or equal to 80 or less than 80, update the column high underscore priced as 0, right? So wherever it is less than 80, it is going to tell us that it is 0, right? So this way, now if you see, you are able to use a condition to create if it is high priced or not, right? Something that you would be able to do in Excel also, something similar you have done here, right? Only thing is here you can run complex if and else statements with using expressions and all, but you get the idea. Yes, so Ravindra sir, correct. Now what we have done is, earlier when we have not run this, only greater than or equal to 80 became 1. So because we have not had a condition for less than 80, wherever it was less than 80, it created as NaN. Now, because we say we have given specified a condition, if it is less than 80, instead of giving it as NaN, it give it as 0. So now we have ones and zeros. Yes, thank you so much. Right. So, why might having this category of high priced be useful? Because now you can just say wherever high priced equal to 1, right? So that is something you can always get columns where high priced equal to 1, right? So that is one thing. That is how you create based upon if condition here. Great. So now what we are trying to do is, if you want to have a complex if condition, right? We are going to say, we're going to use and or operations. So what we are going to do here is, here you can see the layout is simple, same. Before comma and after comma, the condition is going to be same. So here what I'm going to do is, before comma, there will be a condition which will have double conditions. Like, how do we do that? You can see we have subset house dot loc, and in the condition here, what we are saying, there is first part of condition which says if subset house, the price per SFT is greater than or equal to 80, and subset house of total basement is greater than 0, right? Meaning if it has a basement, then write high price with basement. So what we are trying to do here is, we are having a condition and said if the price per SFT is greater than or equal to 80, and if it also has total basement, if there is any value higher than 0, then create a new column saying high price with basement and set it to 1, right? So when you run this and then have subset house printed, you'll have a new column which says high price with basement, right? So now you can see that wherever there is a basement, it is going to give you it is high price, but there is also a basement to it, right? So we are here trying to show how to use multiple conditions, multiple if conditions here. You might be able to use it differently, right? So some places you want to say, if somebody who has came to the game, came to the cricket game, they have come, but they have come after break or something like that. So if you want to do, if they have come after break and purchased something over value of 5,000 or 1,000, so you can do multiple conditions here by using this AND operator and having the whole condition within this brackets, right? So we are using brackets. Within that there is an AND operator, and to the left side there is one condition, to the right side there is another condition. Then what to do if the condition becomes true? Go ahead and set the value as 1 in this new column called high price with basement, right? Yeah, so the logic of putting 1 is, so basically what happens is, what I'm going to do here is, I'm going to print, okay, here let's try to do this. We are going to say subset dot the column, so subsets the column high price with basement. I'm going to say high price with basement, the name of the column, putting single quotes here. Let me see if I'm able to get, yeah, so you're able to get one and nans wherever it is there. Now I'm going to say is equal to 1.0. Okay, or maybe not here. So this will set everything to, okay, so let me undo that. So let me run this portion. Okay, so if at all we want to just get a high price with basement, where it is only one, so we are going to just get that. So let me just try it here. You remember in one of our initial sets, so let me go there and give in the right apps. So it will be helpful if at all we want to get only where there is one cell, right? So let me help myself with the syntax. If I don't want to create a column, but I want to get specific values with condition, what should I give? Yeah, so I think Vinita, we are both on the same page, and we are going to identify that. We had the pandas lecture. Okay, so if you remember, yeah, so this is the syntax. What we are trying to do here is, if you remember in the pandas lecture, we wanted to get something by condition selection based on a column value, right? So I'm going to copy that syntax here. So thank you, Ravindra sir, your question helped me revise this. So now what we are trying to do here is, we are saying wherever it is equal to 1, give me that value, right? So I'm going to say the data frame here is subset house, another square bracket, and I'm going to say wherever subset house is equal to 1.0, give me the values, right? So let me just check if they should bring up. Okay, so let me run it. Okay, let's just try to do greater than 0. Yeah, okay. So, okay, so I think this is helpful. I hope, Vindaman, this is how what we have done here is. Now, Ravindra sir, the logic of putting 1 gives us a way to only filter out those columns, right? So now what we have done here is, we have said subset house wherever the high price with basement is greater than 0, right? Because we have said all of that where with basement is 1. Now you are able to filter out by giving the name of the data frame, and within square bracket giving the condition within the square bracket. If you give condition subset house and the column name greater than 0, now you'll be able to just get 8 columns out of out of all of these columns. You are able to get only the values where it is high price with basement. Okay, I think instead of high priced with basement, let's just get high price. Okay, is it the name high priced? Sorry, not high price, high priced. right? Now, out of whole of the 1,452, 460 columns, there are 332 rows where it is highly priced, right? So you are now, because you have pointed that as 1, you will be able to filter out as 1 and 0. So it is like 1 is for true and 0 is for false, right? So that is how. Here, what I've done high priced with basement is in one column while I was testing, I set all of it to 1. So the way to drop a column is you say subset of the name of the column, and you're going to say dot drop. I think we have dot drop here. Yeah, so dot drop and name of the column and access 1. So we are going to use the same syntax here. Yeah, so even our Rajiv sir says you need not have to memorize all of it, but when you practice it, you're going to remember them. The memory becomes stronger. Can we give condition equal to 1? We can definitely give that, but just here, because it is float or integer, when you're giving equal to 1 or that data type has to be assessed, but then you can always give any kind of condition with them. Yes, Ravindra sir, we can set high, very high, and we can also get details. Like you can say, if it is over 90, SFT price is over 90, you can set as very high. That is possible. So I'm going to say subset dot drop and name of the column and say access equal to 1. When you do this, you'll be able to drop the column if you have made any errors on that particular column, right? So I'm going to drop this because here the actual condition is this, right? So I'm going to run it back again, subset.loc, subset house price per SFT is greater than or equal to 80 and the total basement is over 80, right? So when I run this, you'll have the subset high price with basement as well again. Great. Okay, so I hope this is clear. So if everybody is able to run conditions in this format and make new columns and new values, if you understood this, type U in the chat box. Yes, thank you. So we can do a lot of low price with basement also similarly, right? And now, if wherever you can see that one question was what we have done is here when we have run this column greater than equal to 80, the other values came as nans, right? So you can say less than equal to as set it to 0, but there is another way to do that. That is something that we have learned in our pandas lecture, which was to set fill NA. So when you use this fill NA on your data frame subset house, you can see that it will fill that NA with any value, right? So wherever you find NA, you have to specify the value here. You can give 0, and when you run it, wherever there are nans, it will fill that nans with 0, right? So you can run this and be sure that all of your values in subset house high priced with basement are going to have some value, right? So it will not have nans, no nans will be there, right? So you can see that is possible, right? So fill NA is something that you can do. Okay, so if at all you want to, instead of giving 0 where there were nans, we also saw you can fill them with means or averages, right? So you can say the average of basically high priced with, you can also do mean and all, but because here the column is having only ones and zeros, so you can just say 0 and you'll have wherever nan was there, you'll get 0, right? So this is what we have understood till now. Now, what we are going to do is we'll try to understand on a new data set. So there is another data set that is already loaded here. I'm going to open it on this link. When you open in browser, it will show as comma separated. But this is a loans data by dataset from lending card, right? So JSR even talks about these people. So there's a company called Lending Club, and this dataset that we are talking about is from that particular organization, right? So now what we are doing here is we are going to use this another data set. The URL for that data set is saved in loans_data, the URL. And you can open this in Excel and you'll see the Excel format of it. But if at all you are reading that CSV by using pandas.read_CSV, you'll be able to see the data frame here, right? So we have printed loans.shape. It has 30,000 rows by 144 columns, right? So it is a huge data set, right? So loans.head gave us, the first 5 rows. You can see that a few columns are directly nans, right? So how can you know how many nans are there? We can use the isNull function. Okay, so I'm going to come to our Lending Club example. Here, I can say our data set's name is loans. So I'm going to say loans isNull, and I'm going to do .sum, right? So you can see that there are a lot of columns which have full nans, right? So the first member ID and member ID, all of the rows have nans. So these rows are not useful for us, right? So we'll go ahead and actually drop them, right? Or the other way to do is we can what we are doing here is loans is our actual data frame. We are creating another data frame which is called loans_cleaned of missing values, right? So we are creating another data frame. You can loans, clean loans, you can have any name like that, and you're saying loans.drop and wherever there is missing columns. So now what is missing columns? Now there is another data frame that was created, which is missing columns equal to ID comma member ID, right? So you can see that member ID and ID have whole rows as missing, right? So there were 30,000 rows. Out of that, ID and member ID are not useful for us, right? So we're going to drop them. You can directly go ahead and use the drop command on both IDs. But what we have done here is we have created a data frame with the missing columns, right? So ID and member ID, when you run this, you will have sorry. Yeah, so another way, Suraj, you say is you can go ahead and import it from here as well. Just because it is easier for us to, sorry, thanks, Vinita. Okay, so you can see that there are only nans in this. So that is the reason it is not even printing anything. Okay. Yeah, so now you can see, Suraj, you can use GitHub links. We have given links because it is easy for us to directly give link to you and you can directly import it. Instead of every time give you 11 MB file or 12 MB file, it is easy for us to upload it somewhere and give the URL to you, right? So now we can see that this missing columns, we're going to drop them by using this function, say loans.drop, and we are giving the name of the columns here and say axis equal to 1. So axis equal to 1 will specify the columns. Now, when you run this, you'll be able to see that the first 2 columns are gone, right? So loan underscore amount is the first column, and from there you'll be able to see the other columns also. So if at all this is confusing, it is to me. So what I'm going to do, I'm just going to, if you want to drop, you can just go ahead. First, let me directly do loans dot drop and specify first maybe ID and then say access equal to 1, right? So you can drop it like that. And that should be working. Here it will not work because we are already deleted, so it will not find ID. So it will work when you have imported it as it is. Okay, so let me import it back again. Now you can see that here you'll be able to drop it. Okay, so how do you drop it? Sorry, you have to say loans ID and access equal to 1, right? Yeah, so that should be the way to go about it. Am I missing anything here? Okay, there should be another bracket. Yeah, so sorry, it is square brackets, right? So it's not square brackets. You can just go ahead and use this simple ones. So my syntax issue, my bad. So I'm going to say yeah, so let point me if there's anything that you see, anything I'm missing. Data frame name drop, and you can just directly give name of the column, and that should do, right? Closing parenthesis. Okay, sorry. So there was a useless square bracket. Okay, so you can directly go ahead. Now we have dropped the ID. Now you can go ahead and directly drop the second column, member ID, right? So I'm going to drop the second one. Now you will have the actual column, right? So this is what we tried doing here. And remember to do in place here, because you want to actually update the original. Whenever you want to say in place equal to 1, it's going to make changes in the actual column, the actual data frame, right? So now that we have deleted one of them, so let me first print the loans. What is there? If it is already deleted, you'll not be able to delete it further, right? Okay. Yes. In place equal to 1, equal to true. Great. Right. So let us print loans now. Great. Vinitha ma'am, you have the syntax more stronger than mine, because I normally in place equal to 1, because I think in zeros and ones, true is something, this is something many times happens. Thank you so much, Vinitha ma'am. Right. So you can always go ahead and drop it individually like this, or do it the way we have done it here, right? So towards the end, we have this new data frame, which does not have the ID and member ID, where it is Boolean, correct? Yeah. When I read Suraj, when I read the error, I also understood, okay, it has to be true. Thank you so much. Yeah. So now we are here. We have a little cleaner database. Did it work? Yeah, it worked with some effort. So this is what happens when you run directly. When you run into errors. When you run into errors, becomes more stronger, right? So now it will be, for now, in place. Next time onwards is always going to be true, not 0 or 1. Great. So always go ahead and practice by yourself. Now what we are trying to do here is, if you see this interest rate column, let me first bring that up. So there is one column which is interest rate, right? It has percentage in it, right? So what if we want to clean the percentage symbol alone and have only numbers, right? So how do we do that is something that we are trying to do. We are trying to clean our data further, right? So let me first print the interest rates. So now you can see that the interest rates are with the percentage. And for that reason, the data type here is object, because it has mixed data type. Now what do we do? Can we clear this any single character or any character from a common character from everywhere, right? So you can do that by using the string function called str.strip, right? So what you're going to do is, you're saying loans of the new interest rate, the new column interest rate, update it with the old one and remove, strip it of this percentage symbol, right? So the best way to do is, first, we'll try to, instead of first going for the whole column, we are going to run it on a single value, and if it is working, we'll then apply this to the whole column, right? So let's say there's an example interest rate equal to, which has space before and which has a percentage symbol also, right? So now we are going to use this operation, this string operation. I'm going to say example interest rate dot strip the percentage symbol, right? So I'm going to run this and see if the percentage is gone. Yes, now the percentage is gone. So this way it is sometimes easy for you to check on a separate, maybe another file or somewhere. You can check, okay, if you are able to work it on one column, working that on all of them is easier, right? So that is one way. And if at all you want, if you see there is this another space also, there is leading space before the number, so you can even do that. Say you can have an additional strip and say just empty braces. So when you do this, it will strip the percentage and it will strip the space also, right? When you run this, now you can see that it has removed the leading space and the trailing percentage, right? So if at all, now you can see that this has single quotes, across it. If we want, meaning that it is string, if at all we want to convert this into a float, if you remember in our previous sessions, we had the whole, you can do typecast, you can convert a string into a float, right? If you run this number is now a float number, right? So from something that is not clean, we have cleaned and converted its data type into float, right? If this portion of it is clear, type C in the chat box. So what we are trying to do is, using this function, string function called dot strip, we are able to clear any specific character or space in any particular value, right? So now what we are doing here is, yeah, thank you, Suju ma'am. Thank you, Vinita ma'am. Thank you, Suraj. So you can even, like, for example, if sir also gives an example, if there is AM, like somebody said it was 8 AM, you can even strip AM also. Let me check if that works. Yeah, so you can remove any specific character from the data set. Vinita ma'am, I would also test it, because it works with empty, it should work with single also. So Vinita ma'am's question is, if here we go ahead and instead of giving it empty, we give single quotes. I think should work. Let me go ahead and try. No, single quotes does not work, Vinita ma'am. So we have to keep it empty to strip the single space, right? Maybe let me just try if there is double spaces. Maybe you might, two spaces might work. Let me check. Yeah, so for single space, you have to use as it is empty. But if you have double spaces, you can use this single quotes and give two spaces in that. So it will strip two spaces at once. The argument should be empty, Suraj. Yes. So if at all you want to clear a single space, then it should be empty. If you want to, strip double spaces, you can give two spaces in the single quotes, right? So I think that should be clear. Great. So now, so we have also used float to convert. So now that we are clear on stripping any specific string or symbol out of the column, now we'll go ahead and run it on the whole data set, right? So what are we doing here is, here we have interest rate, and here what we are doing in the interest rate saying, change the old interest rate column to interest rate dot str dot strip, right? So here we are specifying this operations string operation. So that is the very reason we are saying dot str. And when you do this and run it, you can see that here there were percentages everywhere. Now that is gone. So now you can do less than, greater than, everything, right? So earlier with percentage is not possible, right? So that is how. Now if at all you want to strip these, if there are any single spaces, you can do that with the string function dot strip. You'll be able to run that. And if at all you want to convert any specific column into any other column, if you see here, the data type is object, and if you want to convert it to a float, in columns you can use this function called as type, right? We have seen this in our previous revision hackathons also. As type is going to convert this object, the data type, wherever it is as object, you can convert it as float. And let us try to do that and run the head. Now you can see the data type here is float, right? So I hope how we have cleaned one specific column of a few characters. If that is clear, type C in the chat box. Great, thank you so much. So now, thank you, Vinita ma'am. Now let's just say, if at all every time we do not want to, this is something that we have also learned in our pandas lecture, which is dot apply. So applying a function, we have, if you remember, we did, we got marks in one function and returned integer of that marks into 100, right? So if at all we were able to do this, right? If we gave 0.78944, you are able to get the number multiplied by 100 and convert it into an integer, right? So similarly, we can do apply any functions here as well. So why don't we make a function out of what we have done, the stripping percentage and spaces? If at all we want to convert it into a function and make it reuse many other times also, you can go ahead and do it. So what we have done here is, we have created a new function. The name of the function is clean underscore data. And whenever it receives an input X, we are going to return float of string X. I mean, we are saying it as a string. We're going to strip spaces and percentage and return it, right? So this is the function. We have just made a single line function where it will take the input, it will convert it into a float and strip space and a percentage. Now, we'll try to do that. If you remember, in example interest rate, we have 8.47%. Let me run this. Now in example interest rate, there is a space and a percentage. When you pass it to the clean data function, it will just give you the 8.47, right? So now how do you apply this function to the whole data set? You can just go ahead and say, there's a new column that is being created, say loans interest rate cleaned function, and we are saying the interest rate column dot apply the name of the function, which is clean data, right? So when you try to run this, a new column is getting created, which is interest rate cleaned function, and that has used the clean data function that we have created here, right? So you can have any other function. You can have a function which says any other complex, like let's just say a function which specifies the price per SFT. The price per SFT we have done in multiple steps, right? You can write one single function and do apply price per SFT function, and you'll be able to get that, right? So we could have also done that. Now you can see that the percentage is cleaned, right? So this is how we make features. I hope today's session was valuable. So this brings us to the conclusion of today's session. In this, we have tested out on not just on in our Seaborn lectures and all, we have used default data sets. Here we have used some unique data sets. Can we use apply in data frame? I guess yes. Yeah. So we can because data frame, basically we have used it in data frame only, Vinita ma'am. Now you see the loans here is nothing but a data frame, right? So loans is a data frame, and you can use it on a specific column, and you should be able to do that. Should not be a problem. And yeah, so coming to the 1.2 lecture yesterday, there was this, we were trying to, yeah. To the whole data frame, maybe you might have to apply the function to each and every column, right? So I think now your question is clear. You might have to apply it to each and every column, right? So coming back to one question that you have asked yesterday, which was normalize, right? So I think the change suggested was by you was having normalize into 100. Here what you can do is have that into 100 by outside, so that you will get the percentages here, right? So what we have done yesterday was this. When you want to get the value counts, and when you say in brackets normalize equal to true, it will give you values in direct floats. So it is going to give you the percentage of each data set. Okay, so I have to run this, right? So where is the data set? Group is part of the data frame here. I have to run all of these. Yeah, so Disney equal to PD. Okay, so I have to run pandas also. Sorry. Okay. Sorry. Restart and run all. Okay, thank you so much, Vinita. But I guess you understood this, right? So you come back, and now you'll be able to import Disney. Okay, so again, the data set. I hope that data set is here, not in cloud. Okay, so what I'm going to do is, let's try to run it here. So why would I also heavily work myself out there? What is happening there is you have to go ahead and run from the beginning. So identify all. Let's try to do it here. The same normalize function. Okay, we are here. Yeah, so whenever you do a value count, I hope we did value count here also. Yeah. So here, what we are trying to do is, in here, we are saying normalize to true, right? Let me just check. Yeah. So when you do this, now you can see that here we have got the numbers as 0 into, you just give your into 100 here. So you'll be able to get in percentages here itself. So you can see that the group 60, where the values were, how many were, we had 11% of data which had 60 as a value, right? So if at all, so I think that answers the question. Thank you so much, Vinita ma'am. And the other question that Vinita ma'am has is, can we apply this function to the whole data frame at once instead of applying it to columns? I think you would also want to experiment with it, and I would also try it, and we'll come back with the answer to that tomorrow, if it's possible or not, right? Thank you so much, Vinita ma'am. Thanks, everyone. If there's any other question, you can put it on the chat box. If everything is clear, type C in the chat box. But thank you so much, Vinita. But I would definitely say, if you do not practice, it is something I could tell conditional C. So it says, yeah, thank you so much. So if it is not practiced, it will definitely fade away very easily. So I would request you to get into the habit of practicing it either parallelly or after the session. So after the session, it is because you're already spending, let's say, roughly 60 to 90 minutes on the hackathons. It's always good to run them there itself, and you'll get into queries, and it becomes easier for us to needs practice, right? Suraj says that. Yes, Ravindra sir. So it's very easy. Once you have the collab file, it's just a run only. So when you run, you'll run into errors, and when you run into errors, it becomes more clear. Practice parallelly and afterwards too. Yes, thank you so much, ma'am. Yes, I think we're all on the same page today. Thank you so much, everyone, for joining in for today's hackathon. So this week we had three hackathons of AI, and similarly we'll have our next one Tuesday, Friday, and Saturday. So you'll also receive the mails of the same. Thank you so much. If at all you want to go through the revision of recordings of these same hackathons, it will be in your inner circle along with the collab files. Else you can just go through the actual lectures by the primary faculty. Great. Thanks everyone for joining in, and hope you have a very good weekend. Thank you. Thanks, Suju ma'am. Thanks, Suju ma'am. Says thanks to everyone. Thanks. Thank you, ma'am. Thank you. Thank you.